A person takes the elevator from the third floor to the 8th floor of a building where there is 3.7 meters between each floor. The elevator moves at a constant 1.5 meters per second. How long does it take them to reach the 8th floor? Alright, so there's a few steps that we're going to follow when we solve physics problems. We'll talk through each step in this example, and then we'll move through them faster as we do more problems. First, let's read through the question a second time to make sure we understand what's going on and what exactly it's asking us to find. We also want to pick out the important information that we're given. That could be numbers, directions, or important words or phrases that have a specific meaning in physics. A person takes the elevator from the third floor to the 8th floor of a building where there is 3.7 meters between each floor. So this elevator is moving upwards, and the third floor and the 8th floor are probably important, and we get a number for the distance between each floor. So we could probably figure out how far the elevator moves. Next, it says the elevator moves at a constant 1.5 meters per second. That's the velocity of the elevator, which we can tell from the units. The fact that the velocity is constant means that it's not accelerating, so that might be important to remember. Then it says, how long does it take them to reach the 8th floor? So the question is asking us to find the amount of time it takes for the elevator to travel the distance from the third floor to the 8th floor. Okay, next, let's draw a picture so that we can get a better idea of what this looks like and so we have something to reference as we work through the problem. This question is pretty simple, but it's good to get in the habit of drawing a picture whenever you're working on a problem. Here's an example of something we could draw for this one. We have the third floor and the 8th floor, a line to represent the distance between them, and a rectangle for the elevator. It's up to you how much detail you want to include in your picture. All of the problems we're going to deal with in this course are pretty simplified versions of real-world scenarios, so we only want to include the stuff that's relevant to the problem and the physics variables and equations that we work with. For example, we don't need to draw the building, the cable attached to the elevator, or anything like that. And actually, it might be good to just represent the object that we're focused on using a dot. Most of the time, when we talk about the motion of an object, we're describing the motion of the center of the object, or some point on the object. This elevator has some height to it, and it might get confusing trying to figure out how to align the rectangle with the floors, and if we should add some extra distance for the height of the elevator. So we can draw an elevator and just focus on the center of it, or we can just draw a dot to represent the elevator. Now let's label our picture with some of the information we're given. We have the starting floor and the ending floor, and the elevator is going to travel some displacement in between them. So let's label this as delta y, since we're working with the vertical direction. The elevator is moving up with a velocity of 1.5 meters per second, so let's draw a velocity vector, which is just an arrow, and label it as Vy for the velocity in the y direction. For simple problems, you might be able to just think through this without drawing anything, and without using these variables, but we're going to look at things using the terms, variables, and equations that we learned and that we use in physics, so we can start to see everything through this consistent physics point of view. Now that we have a picture, let's write down the given information and any assumptions we need to make to solve the problem. Most of the time, this will just be variables and their values, but let's write all of the information we're given. The elevator is moving from the third floor to the 8th floor, and we're told there's 3.7 meters of height per floor. We're also given a velocity of 1.5 meters per second. You can write the given information in the picture or on the side like this. Now let's write down that we're trying to find a period of time, which we represent with delta t, or sometimes just t. Finally, let's write down any important equations that we might need to use to solve this. We have an object moving at a constant velocity, and we want to find how long it takes to travel some displacement. You might be able to remember the equations, but we can check the equations in the study guide or on an equation sheet, and look for which equations have the variables we're given and the ones we're trying to find. This velocity equation should be enough to solve this problem. We're trying to find time, delta t, and we know the velocity, vy. The displacement, delta y, is what we call an intermediate variable. We're not given its value, but we can find it with the information we have. Alright, so now let's work through the problem. First, let's find delta y. In this example, the elevator would travel 3.7 meters for each floor, so we can multiply the number of floors times the height per floor. That's 8 minus 3, or 5 floors, times 3.7 meters per floor. So delta y is 18.5 meters, which is how far the elevator travels. Now let's use this velocity equation to solve for delta t. Another thing to mention here is that you can work through the math whichever way you prefer. One option is to rearrange the equation first to isolate the variable you're trying to find, and then plug in the numbers after. If we multiply both sides of the equation by delta t, and then divide both sides by vy, now we just have delta t on the left, which is what we're solving for. Now we can plug in the numbers that we have for each variable. 18.5 meters for delta y, and 1.5 meters per second for vy. That gives us 12.3 seconds for delta t. The other way you can do it is by plugging in the numbers first, and then rearranging and simplifying the equation after that. This might be helpful if you're working with a lot of equations and variables that you already have values for, so you can just do the math as you go along. However, keep in mind that every time you calculate something and simplify the numbers, you probably won't keep track of the units, and you'll need to make sure you use enough decimal places so that your final answer is accurate. The first method might be easier in most cases, especially if you're combining equations, because some of the variables might simplify and cancel out. Also, there won't be as many chances for us to write down a wrong number or lose track of the units. You can also go back and forth between plugging in numbers and rearranging the equations as you work through a problem. So now that we have our answer, let's check that it makes sense. Some things to look for would be the sign, the magnitude, and the units. In this example, the elevator only moved in one direction, and we were given a positive value for the velocity, so we're really only working with positive numbers. Plus, we're never going to have a negative value for time, so our answer should be positive. The magnitude, or the general size of the value that we got, seems reasonable. It's not taking hours or less than a second to travel 5 floors. One thing we can do is plug our answer back into the equation we used, along with the given information, and make sure the equation is true. If we do that, we see both sides are equal, so the value checks out. We also got the right units for time. So let's go ahead and call this one solved.